Welcome to Spare Part Identification Process Descriptions, and thank you for your interest. We hope you'll take time after this short presentation to explore the other Triad Unlimited presentations on YouTube, follow us on LinkedIn, and visit our website to see all our service and training offerings. Spare part identification links the inventory management storeroom function to the asset management program. By identifying and prioritizing spare parts, we can provide a risk-based input to the inventory management program. As in the previous functions, RE4, spare part identification, has 4 processes. Again, the cookbook and the recipes. Process 1 is a spare part type decision matrix, which is essentially a stock, non-stock recommendation from reliability to the storeroom. Then, process 2, we have to identify the spare parts necessary to support proactive tasks. That way, we make sure that we don't have stockouts or other part unavailability for a task that's coming up and needs to be done. Then we have to be sure that we document spare parts consistently so that we can compare them across the business, and perhaps one site can hold spare parts for all the other sites of a certain type, right? And we can start to leverage our geographical location. We can start to leverage our real estate availability for storage and those kinds of things, because we can identify accurately who has what without guessing about it or missing something because it's not accurately documented. Finally, in process 4, just like the other processes, we're going to establish some relative importance of each spare part to the business by prioritizing them based on typically the failure mode priority. Linking spare part requirements to failure mode priority gives us clear criteria to provide risk-based input to the inventory management program about what to stock or not to stock from a reliability perspective. By identifying the parts necessary to support proactive tasks, we reduce the incidence of stockouts or other part unavailability issues. Documenting spare parts consistently helps ensure correct parts are procured and reduces duplication of spares because of inability to compare record data. Prioritizing spare parts provides the storeroom team with insight into which parts are considered by reliability to be important to asset management. This is a handoff between reliability management system and the spare part management system within the AMP framework. By classifying parts as important to asset management or not, we can compare those requirements to the actual spare parts inventory and then close any gap between the two. The idea of classifying spare parts is to provide an input to the spare part management team about which parts are necessary to support proactive maintenance tasks and the relative importance of the associated failure modes. This input should be a factor in that team deciding whether or not a part should be stocked in the storeroom. One of the major flaws in most spare part management systems is the absence of clear criteria on when to stock an item and when not to stock an item. The absence of guidelines forces ad hoc and inconsistent decision-making. The result is that parts not needed are stocked, and parts needed are not stocked. Utilizing failure mode priority to drive spare part recommendations is a data-driven, risk-based approach to this decision. There is no point in developing tasks if we don't support them by ensuring that the parts necessary to perform them are available. We have to anticipate that on-condition tasks might require parts. Restoration and discard tasks certainly will, and the run-to-failure strategies will require replacement parts by their very nature. But what about a task where parts aren't clearly specified, like a general inspection? Now, this would be a problem if we hadn't already clearly defined and prioritized our failure modes, wouldn't it? But because we did do that, we are almost sure to have the parts in hand for critical failure modes. And if a problem is discovered during a general inspection, we can be reasonably sure to have the necessary parts on hand to deal with any findings. It's always best to analyze parts requirements for assets and consider the needs of the overall population of like assets. By doing this, you avoid overstocking resulting from considering each task separately, and you avoid understocking by considering the entire population of assets that might require a certain part. An example would be if we had 100 of identical pumps, and each one of them use the same kind of mechanical seal. We don't overstock by buying 100 mechanical seals, one for each pump. And we don't understock by not knowing that we've got 100 pumps that use the same seal. We're just getting clarity around the population and the usage of like spare parts. And there's no point in considering failure modes that don't have tasks from a parts perspective. Have you noticed how we visited consistent documentation for assets, failure modes, proactive tasks, and now for spare parts? Why do you think that's the case? It's because correct and complete data records are essential to effective asset management. In the data world, one missing or incorrect value renders the entire data population at least somewhat suspect. Describing spare parts consistently benefits everyone who interfaces with the information. Here are some suggested data fields that can be helpful toward establishing rules that define the minimum required data related to spare parts. Spare part prioritization is a handoff point between the reliability and spare part management systems. The input from the processes associated with spare part identification are not the only input into the spare part management system. Note here, starting at the top, that spare part prioritization is really broken down into 4 categories: failure mode priority, as we've been discussing, but also turnover. How much of the spare part do we typically use or expect to use? The lead time, how long does it take to get the spare part when we realize we need it, and how much does it cost? Again, we set up criteria as we have before and use that to develop a spare part prioritization score by combining all of these elements together. There are other inputs related to stocking strategies after spare part priority is established, like carrying cost and shelf life and obsolescence and real estate limitations and other things that are outside the scope of reliability. The key is to ensure that there is a defined interface between the management systems, between reliability and spare parts, that allow a clean handoff and which both systems respect consistently. To summarize, spare part identification requires selecting the appropriate spare parts based on failure mode priority, ensuring all proactive tasks have the required spare parts, consistently documenting spare part data to ensure duplicate spare parts are registered, and prioritizing spare parts to drive spare part management system requirements. This concludes the spare part identification process descriptions presentation. Thank you for participating.